Hello everyone, and welcome to part 4 of my matter and periodic table review videos. In this video we're going to talk about periodic trends. So we did a little activity in class where we created our own periodic tables. Now I'm going to talk to you a little bit about the two guys who came up with some of the earlier periodic tables. So the first guy's name was Mendeleev. Now this guy had 60 elements and he sorted them by weight, by atomic weight, how much each atom weighs. And what he noticed was that there was trends in the properties of the elements as he organized them. So basically what happened is he laid them all out in order and he would notice patterns in their properties. Like every 10 elements he got a gas, or every 10 elements he noticed that one of them was a metal, things like that. Now he actually left some empty spaces in there because he predicted that there was elements that were missing based on those properties. And what actually ended up happening is that later on they discovered some elements, some new elements, and they fit perfectly into those empty spaces and they fit with the properties that he predicted. So he was able to use these patterns that he observed to predict what these unknown elements, these undiscovered elements would be like. Now, the next guy to do the periodic table was Moseley, and he was working with Rutherford on different metals. So he took 38 metals, and instead of sorting them by weight, he sorted them by nuclear charge, which was really just basically the number of protons. Now, what he ended up doing is calling this number the atomic number, and because it's so important. So he noticed that the patterns that Mendeleev noticed were even more solid when he sorted them by atomic number instead of atomic weight. He noticed more clear patterns. Now this led to one of our laws, the periodic law. Physical and chemical properties of the elements are periodic functions of their atomic number. So basically, as the atomic number goes up, okay, we're going to notice patterns at regular intervals. So every 10 elements we'll see a gas, every 10 elements we'll see a metal, things like that. And we'll notice these as we look through our periodic table as well. So we actually stuck with Moseley's idea of arranging it by atomic number because the patterns were more consistent with that. And so what ends up happening is elements with similar properties fall into the same columns or groups, which we talked about those groups in the last video. Now, I just want you to highlight some sections on the periodic table, and we're going to use these sections to help us keep track of the different parts of the periodic table. Now, the first thing is we're going to move helium over here, and I'm not going to talk about why right now. It's just going to make it easier for this part, okay? So the S block is these two columns right here, okay? So this is your S block. I'm going to color it in because I feel like it. Okay. The P block is this section right here. Okay, that's your P block. The D block is the area in the center. Okay, so that's your D block. And the F block is the last two rows at the bottom. Okay. So when I refer to different sections on the periodic table, you might hear me talk about them as the S block, the P block, the D block, or the F block, and this is just your little key to help you remember which one's which, okay? Now, let's talk about these trends that our scientists noticed. So what they noticed is as they looked at the periodic table, there were certain properties that increased or decreased as we went across or up and down the periodic table. Now I want to define some of these things for you and then show you the patterns, and then we'll do a couple examples. So the first one is ionization energy. This is the energy it takes to remove an electron from an atom and to make it an ion. And this goes very much hand in hand with this term electronegativity, an atom's ability to attract electrons. They're kind of the opposite of each other. So here it's saying it's how good they are at attracting electrons. This is measuring how good they are at getting rid of electrons. So when we look at these patterns, sorry. It's not how good they are at removing them, it's how much energy it takes to remove them. So if it's really, really good at attracting electrons, it really, really wants those electrons, it's going to take a lot of energy for them to take the electrons away from it. If it's bad at attracting electrons, if it doesn't really want the electrons that much, it's not going to take a lot of energy. So when we look at these trends, they actually go together because they're both related to those electrons. So as we go up the periodic table, ionization energy and electronegativity increase. As we go from left to right, they also increases. And this has to do with valence electrons. So on this side of the periodic table, the atoms are only a few electrons away from having the amount they want. So because they're so close, they don't want to give those electrons away. So it's going to take a lot of energy to take them. And because they're so close, they're going to really, really, really want those last couple electrons, so they're going to attract them closer to it. So these have high values. Now over here, it's the opposite. They have less electrons, so they're not very good at attracting electrons, and it's not going to take a lot of energy for them to take them away. So it kind of has the opposite pattern. Now, atomic or ion radius, this is just how big your atom is. So if I draw an atom, my radius is from the nucleus to the very edge of the atom. So this is just telling us how big is our atom. Now, this one seems a little silly. Now, obviously, as we go down the periodic table, they're going to get bigger because we have bigger atoms, more protons, more neutrons, more electrons. So it's going to get bigger as we go down. But what doesn't make sense is as we go to this side, it also gets bigger. This has to do with how well the electrons are being held in. So over here, there's more protons in the center, so they're good at pulling those electrons in. So it's going to make, over here. There's more protons in the middle, so they're better at pulling the electrons in. So what's going to happen is the atoms are going to actually be smaller on this side. More protons, smaller atoms, because it's pulling the electrons in closer. Here on this side, there's less protons for electrons, so they're not as good at pulling those electrons in, so the electrons get to stay further away. So atomic radius, it increases as we go to the left, and it increases as we go down. So the biggest atoms are over here, and the smallest atoms are over here. Now, reactivity depends on if it's a metal or a non-metal. So this kind of tells us how good it is at reacting or how strongly it reacts. Now, for non-metals, they react more as they go up to this corner over here. So as we go to the right and up. Metals, they react more as we go down and to the left, okay? And this has to do with their number of valence electrons. So let's do a couple examples. I'm going to draw in some of the elements that are on this periodic table. So I have, let's just do some right over here. I'm trying to remember my elements. Li, Be, Na, and Mg. Okay, can we see those? Yeah, just barely. So if I was trying to decide which one had the higher ionization energy, Li or Be, which one's higher? So if I look at my arrows, ionization increases as I go up, and it increases as I go to the right. So here they're next to each other. So if I look at this arrow, the ionization energy increases as we go to the right. So Be is going to have the higher value. So I'm going to draw a greater than sign. What if I was comparing Li and Na? So here Li is on top and Na is on the bottom. So if I look at my ionization energy arrow, as I go up, it increases. So the one higher up is Li, so it's going to be the higher value. Basically, the arrows are going to point you to the answer. If it's pointing up, the higher up one is your answer. If it's pointing to the right, your one to the right is your answer. Let's try electronegativity. Let's compare the same elements. Okay, so here, electronegativity, it increases as I go up, and it increases as I go to the right. So if I compare Li and Be, that arrow is pointing to the right, pointing towards Be, so it's going to have the higher value. Here, Li and Na, we look at the electronegativity arrow, it goes up, so the one higher up is Li, so it will have the higher value. So we're following the arrows. Let's do atomic radius. We're going to compare the same elements again. Oh, I drew over here, so let me draw it over here. Okay. So if you notice, these had the same trends because the arrows point in the same direction. So now let's look at atomic radius. So here, Li and Be. Atomic radius increases as I go to the left. Li is closer to the left, so it will have the higher value. Over here, atomic radius increases as I go down. Na is lower than Li, so it will have the higher atomic radius. Now these are all metals, so let's do this for metals first. Okay, so if I compare Li and Be's reactivity and Li and Na's reactivity, so for metals, we have to look at this one. It's down and to the left. So this is pointing towards the left. So if I look, Li is further to the left, so it's going to have the higher value. It's pointing towards the bottom, so whichever one's furthest to the bottom, which is Na. So now let's try nonmetals. Let me add some nonmetals to my periodic table where you can see them. So here we have F, Cl. What's next to F? Hold on, I know this. It's oxygen. And below oxygen is sulfur. Okay, so let's compare oxygen and fluorine and oxygen and sulfur. So if we look, nonmetals increase as we go up. So if I look, oxygen and fluorine, it goes up and to the right. Fluorine is further to the right, so it's going to have the higher value. Nonmetals go up, so the one that's higher up will have the higher value, so that's going to be oxygen. Okay? So the key is you got to follow the arrows. I will give you two elements to compare, and then you're going to use these arrows to help you figure out what has the higher value. If the arrow points up, the one higher up will have the higher value. If it points down, the one towards the bottom will have the higher value. If it points to the right, the one on the right will have the higher value. If it points to the left, the one to the left will have the higher value. But the reason this works is because of those periodic trends. When they organize the periodic table, they notice these reoccurring patterns. And we'll talk about more why those patterns occur as we go forward. Thank you so much. If you have any questions or concerns, let me know.